And all right, let's start. All right, so really welcome everybody. Welcome. This is the second session, but it's Unit 3 and Unit 4 of M2, and we have a good turnout today. And we're going to do so if M1 was just about building the basic chassis and doing the basic navigation, and Unit M2 is then increasing your programming and making it a little bit more reliable using sensor data. So that's what we did yesterday. We did sensors, we did ultrasonic touch, and we did the color sensor. And today we're going to modify the structure of your robot to make it that we have powered attachments as well. And so powered attachments usually use gearing for greater control. So that is Unit 3. We're going to do some gearing, and then we're going to do powered attachments. And then the last unit of M2, I'm going to show you some examples, and we're going to go through it. And then hopefully we'll have some discussion as well about where you see the solutions. And there we go. All right. So let me start my presentation. Let me just go back again. There we go. All right, so this is Unit 3, and we're going to do gearing and powered attachments. So if you remember from M1, we just used like bumpers. That was just passive attachments. Now we're going to use powered attachments. And with powered attachments, with that power, with you being able to write computer programs to control your arms and your attachments that go up and down and they grab. So with that, we need gearing. And so gearing is a kind of linked with powered attachments. All right. Again, if you go to the MOOC site and you look up M2, there is an overview document, and you'll see under Unit 3, Unit 3 has got two parts. The one is about the gears and the models and how you program to control the gears. And the second part is powered attachments. Now, we all realize that this is a lot of learning packed into one unit. But you as the coach can unpack it. We're busy with our lesson plans, and so there's a lot of learning happening, and you can do multiple lessons out of Unit 3. All right. I would encourage you to build all the powered attachments possible. Okay. I was going to show you this video as well. Maybe at the end we can do it, but this is phenomenal what can be done with gears and just how one gear moves another gear. Let me get back to this video. All right. So what's a gear? Well, a gear is any part that rotates. So any part of a machine that rotates, that is a gear, where the teeth mesh. And this wording is actually in the technology syllabus. It feels like forever and ever ago. But technology used to have these as... Just mute that microphone. Thank you. All right. So why do we bother using gears? Well, you have to be able to change speed, direction, and torque or power. And so anybody, all of us who have valid driver's licenses, we know that in fourth gear, we have a lot of speed. We don't necessarily have the power. So when we go up the hill, we go down a gear. So there's speed, and there's torque, and there's direction. Okay, and it's about the power trying to get you somewhere. So what I'm going to show you some of the basic structures of gears, and maybe they look familiar, but it's in your box. All right, so these are the gears, and the gears that come in the robotics kit vary, maybe to greater or less extent. But whenever you have 3 gears meshed, that becomes, if the power source is on this gear, then it will transfer the rotations via this middle one, which is called your idler, and then this is your driven gear. So this is your driver, the gear that's attached to the motor. So if this gear is attached to the motor, then this will drive, that'll be your idler, and that'll be your driven gear. Okay. Again, there's a transition or a rotation of movement. So if you attach the pinion, this little gear here, to a power source, and it's going to turn, then the rack is going to turn linear. All right, so it's going to, not turn, it's going to move linear. Turn. It's going to move linear, and again, there's an A missing there. All right, and then sometimes you put gears at 90-degree angles, and we call that a bevel gear. So they're kind of at 90 degrees, and you turn one, and then the other one will turn, and that's a bevel gear. So you're transferring movement from this plane to this plane at 90 degrees. Again, a change of of orientation as well. All right. Some of the gears are easier to use than others because and just for the simple reason that they're more reliable. Okay, if you're using spur gears, you have to ensure that the meshing remains rigid. Okay, so that is one of the criteria. The worm gear, you have to make sure that it can move, and the knob gear is really the easiest way to introduce gearing to your learners. The power attachment for the Riley Rover, the cargo loader, has got knob gears, and it's the easiest way to get learners used to what when one turns, then the other one turns, and so gearing as a concept. All right. There's a really cool reference there to gears and boxes, and so and I've also got some literature I'll show you now. Okay. All right. So basically, when you're building a spur gear train, you've got a whole lot of gears in line, and that's what I said. So if these are all spur gears, different spur gears, but you can see they're all meshed very well. There's a meshing and there's a meshing. So the one moves across every second. So if this one goes clockwise, then this one will also be going clockwise because this one will be going anti-clockwise. Now, and that brings me to another point. You can explain it to your learners. You can explain it and explain it, but it's not going to go in until you give them 3 gears and tell them to put it onto a beam and turn one and see what happens. And then turn one slower and see what happens. And turn one faster and see what happens. And make it bigger and smaller and make it different orientations. The only way that the learners learn about gears is by doing. And so I'm also going to show you a book, maybe. There's an EV3 ideas book. I don't know whether there's one for Spike Prime yet, but the ideas are there. You can just use them for any gears. And getting learners to build models with gears. Build them. Actually, physically build them. This is learning through doing and playing, but learning through doing. All right. So again, this is your rack and pinion. So if you want the rack to move left to right that way, okay? Then the pinion has to rotate. Can you see it's going to push it out? So if you turn the rotation of the pinion the other way, then the rack is going to move the other way. Okay. But this is learning through doing. So get them to build this little structure and to actually operate it. You can't move the rack, though, to move the pinion. It's the pinion that has to be attached to the motor source. All right? It's rotating. Okay? You cannot force a motor to turn. You have to program the motor to turn. You can program the motor to turn, and then the rack will move backwards and forwards. Okay? I hope that is clear. All right, with the spur gears, please just get into the habit of when you use gearing to use time in seconds. Program it in seconds. And I'll tell you why, is that the rotations might not be able to complete depending on your starting position. And then you're going to have a robot that doesn't move. All right. So when you code or when you program to get a gear to move, use the time and change power settings to 50%, maybe 100%, and then see the impact, and let your learners tell us what the difference is. Okay, you've got to be able to describe the impact. Okay, exactly so for a bevel gear. All right, so if you're connected to the bevel gear, you have this structure. There's an axle, there's a gear, here's a gear, and here's a gear, and then there's an axle. All right, so connect that axle to a motor, let it run, see what happens, and then you can also say, change the power setting to 50 and 100, and then see what happens. Change it to 20 and see what happens. All right, and then describe the impact. The learners need to learn by doing. Okay, I think I've said that already. Okay, so, but the learning of gears is by doing, but there are quite a lot of examples. And I really need to highlight the need for dog gears. Dog gears is like your next level. And it is important when you are starting to attach powered attachments that you can attach and detach to the robot. Dog gears is a really awesome mechanism. I'll show you an example now. Okay, and there's spur gears and there's bevel gears. This is just one example that I selected. Okay. Oh, sorry. And claws. So claws will be somewhere where it's controlled by gears when it closes, when it collect something. All right, but don't only watch it yourself. Let your learners also watch these videos, that they also have some input. All right. Okay, so that is all about gears. I know it was very quick, but you understand that gearing, you build the gear models and then you use that in the application in powered attachments. All right. So if you've got powered attachments, what's the purpose? All right. So remember when we did passive attachments, I said look at the verbs. Look at the verbs and say what can you do with powered attachments that you maybe can't do with passive attachments. For one, when you use powered attachments, you're using one of your ports. So you're using a motor and you're using a port. So you will have to program it. And where you put your powered attachment, well, depends what you're doing. All right. If you're going to go forward and pick something up, it's got to be in the front. Sometimes it's got to be a little bit higher so you can put it on the top. Wherever it is needed, that's where you need to put it down. Okay. But you must be connected. And here's the little bit of a difference. You connect it as a structure. So you've got pins and connector pins to connect it as a structure. But if you want to have it functioning, you have to have a wire. And I tell you now as coaches, make sure that the port where the wire for the function of your powered attachment is exactly the same as in your programming, because otherwise your powered attachment is not going to work. Okay. So just as an example, this is from the Riley Rover robot. So there's your basic robot. This here is called a cargo loader, and there underneath there is the motor, and there I said it was the knob gears. There's a bigger picture coming. All right. So this one is knob gears, and it attaches here into this frame here, and it attaches in, and then you still need to put the wire in. And that is awesome if you can just lift things up and lift things down. That's great. However, can you see that if you just detach it on the sides and turn it around, you can also bring it down and pull things towards you. Okay, so I would definitely advise you start just with that powered attachment and then give them another challenge to say, okay, so how do we adapt this attachment for something else? This is the gripper gear, which has got a worm gear and 2 spur gears. It's great, but it has to be very accurate. All right, you have to have a starting position. You have to know how far you can go. You cannot overcross, because once those arms overcross, the whole mechanism becomes unstable. All right. The other thing is that this is not very well attached. So in terms of a rigid structure, this is not a very rigid structure. It comes loose easily. But then also it might be that you are going to need a different kind of grabbing mechanism, and then you need to maybe modify that. I would definitely put another beam in to keep that meshing from unmeshing. Okay. I will show you some videos now also where Mr. Hino has got a whole lot of videos, and he can do an entire First Lego League challenge with just this cargo connector attachment and various forms of it, various modifications of the powered attachment. Okay, so you can grab, you can lift. If you turn it around, you can push or you can pull. And it's usually a multi-purpose one. So it's really cool if you have the same attachment and you just quickly modify it and you do something else. Remember, usually in competitions, you have to do multiple missions within a very limited time. And so if you have one singular attachment that you can use for multiple things, that's awesome. Okay, so if you have an attachment that can grab to collect and also grab and release, so you hold it and then you release it, exactly the same mechanism. All right. Or if you have something that can lift to carry, you can also drop. You can carry it and then you can drop it. So you've got to look very carefully at maybe making multi-purpose robotics power attachments. All right. Where do you attach your passive your powered attachments? Where they are needed. Okay. And just by default, A for arm, port A is usually an output port to attach the first arm. And you can see it doesn't stick out very wide. So there's the gripper and there's the cargo loader. All right. Here we've got an example of spur gears meshing with a worm gear. And here we have got example of 2 knob gears used as bevel gears where they are at 90 degrees to each other. Okay. All right. And then you can modify the gripper arms. So you can make them longer, you can make them shorter, you can, whatever you want to do. All right. All right, so this is just next, this is up a close up. All right, so for the cargo loader, there's the two knob gears. The one knob gear is attached directly to your motor. So your motor is going to turn it like this. All right, so if you turn it like this, then this knob gear is at 90 degrees to that. But this knob gear here, is attached to a axle. Okay, and so this axle will then lift the whole structure and lower the whole structure. Okay, they're in there. All right. And then the arm can move up or down. Okay, so why do we need to use time? So if you start up and you go down for one rotation, it's going to hit the floor, and then the arm can't complete the rotation. Okay, and then your robot's just going to get stuck. A robot is very obedient. It'll only do what you tell it to do. However, if you have the arm up and you program it to go down for 1 minute and it hits the floor and it can't go further, it waits till that 1 minute is up and then it continues. All right, so it's a forgiving way in case the program is not 100% accurate. Okay, and then the arm will move up and down. You can see it. And also remember, it can't go it can't do 180 degrees. It can't do 360 degrees because it'll hit on the robot on the one end and it'll hit on the ground on the other end. That's its range. Okay, so it can go up as far as the robot is and it go down to the floor. That's the only motion it's got. All right. So just as part of some good programming, it is always a good idea to have, before you start, to have something that says reset arm, and then you make it come up, say for one second or 2 seconds, just to come up so that it's in the same starting position, and you know your robot is like really steady. Okay, and then we can go. Okay, so now with the worm gears, here's your worm gear, and it's also attached to the motor, and there, just also one thing, just check this little here where your gear is in here. It mustn't be in the cross or in the axle. It must be your axle must be able to freely move. Many times students use the wrong, or learners use the wrong connector here, and then the motor won't move and you're going to damage the motor trying to make it move. You must make sure that the worm gear actually turns. All right, so as the worm gear turns, so the spur gears will actually move inward or outward. Okay, and so that controls the arm, because the arm part, the gripper part, is actually attached to the middle of the spur gear. Okay, again by another axle. Okay, and so there's the meshing, there's the two spur gears, and they're attached to the arms. Okay, so with all things, then we make activities, and so in your activities, every single power attachment should be built and attached to a robot, and then you need to test it for programming. But before you can just like jump ahead and write a program, it's always good to just take a little bit of time and say, if it goes for 2 seconds clockwise or anti-clockwise, is it opening or is it closing? All right. All right, so to move the arm up, you have to have a starting position. Then you test whether positive is up or down. So see if you go positive, does it go this way or does it go this way? All right. And then you need to wait before you change direction from up to down. So if you're going to go up and down, you can't do it because then you've got, it's just momentum. So if you're going to go down, wait for 1 second and then you come up. All right. Or if you're going to lift something, come up, hold it, and then move. All right. And again with the gripper as well, you need to have a starting position. Are you going to open or close? You must know where your starting position is. All right. And then you test first. If it's open and you want to close it, is that clockwise or anti-clockwise? You must test it. All right. And then you must always control with time, because arms mustn't actually cross over. Okay. Because that's when the meshing gets all messed up. Okay. All right. So I was telling you, why do we use building instructions? We use building instructions. We need to create a frame of reference. Okay, so here, these are the two links I was telling you about. So he has used, this is Mr. Hino, and he has adapted just the normal cargo loader. All right, normal cargo loader, made it longer, made it shorter, made it wider. So you've already done with the building instructions, you've built a cargo loader. Great, awesome. And then you push your learners to say, okay, so can you make it like this, or can you make it like that, and you can do something else here. And so this is exactly that, where you have a powered attachment that's adapted. So you have building instructions for powered attachments, you build, and then you say, all right, now we adapt. And once they've adapted, you kind of, they're on their own to design their own thing. All right. So there's a whole lot of little activities you can do, and I really would encourage you to find some and apply it for a specific situation. All right. So lift something up, move forward and drop it, or hold something, go forward, turn around, and then drop it, or something like that. All right. There are a whole lot of activities you can do, and hopefully this is motivation, because you have what is known, you just need to maybe adapt the attachment for whatever the challenge is. All right. Yeah, I'm trying with additional items. I'll tell you now, to grab a water bottle, an empty water bottle is easy, but to grab something like a tin of condensed milk is not that easy, because once you hold it, it's quite heavy and it doesn't move. All right. All right. So I've got some recommended references for powered attachments. And this is not me, but this is one of my winning design. I have, oops, sorry, here we go. Okay, I'll show you now the books. So let me show you quickly. Let me just escape out of here and stop sharing. All right. So what I was telling you about this idea is for gearing and powered attachments, and there's some really good just mechanisms. Okay, so this is this book here. Can you see it there? There we go. And these are a whole lot of these little motors and things that the learners can build, just models, and you can include it in the robot later. But it's to start getting the thinking of how do I build and design attachments. All right. If you really want to go to the end of the earth, there's a whole. This is very technical though. This is a there we go. This is a very technical book, and it shows you how to build these very technical attachments. I wouldn't go for that when you start out with your learners. You might scare them off. You want to keep encouraging them. So maybe keep that as this is a surprise, maybe for one day down the line. But where I really got a really good understanding is the Winning Design book. There is a PDF available on the internet somewhere. My other book is busy falling apart, so I bought myself a new book because it's not falling apart. But the other one was also bitten by the cat. So this is for the EV3. And it obviously needs to be updated for Spike Prime, but it's a really good kind of overall for building robots. You'll also see that the robots have got the standard frame around it. For a long time, that was one of the designs. So we went from Riley Rover to Winning Design with a frame around it, and then we moved on to other structures. And so that's that. And then last but not least, no, that's all the books that I have. Okay. All right. So I'm just going to quickly just pause here. Are there any questions? Any questions? Any questions? I know the chat's not available, and we'll do something about that for next month.
Dr. Gijs, we have
just one comment
okay.
that I've seen on programming my own is if you put the speed as too fast on some of the gears, you actually get noises and the robot really doesn't want to perform. So play with the speed, make it slower, make it faster, put it higher and lower, because it's really not effective if you just try and whiz in, do something and come out. Take your time.
Absolutely, Almarie. I couldn't agree with you more. Yeah. Take a time to do it properly first. Absolutely. Yeah. Thank you for that. Welcome, Casper. All right. Anybody got anything else? All right. So now I'm going to open. I'm going to go through a session of application. So how do you bring all this stuff together? And now we're in Unit 4. Now we're going to Unit 4. And how do you put it all together to actually solve a problem? And so I'm going to go through a number of problems now. I'll present them to you, and you can discuss them with me and the rest of the crowd. But I really would love some interaction. And if you have any ideas how to solve this problem, you're welcome to do that. And then after the session, I will put my other camera on, and then I will hopefully my robot will behave. I'm hoping. Okay, everybody okay? Everybody looks okay. Everybody's got tea and coffee or something like that. All right. I need to really thank you. I need to thank you for coming yesterday to units 1 and 2, and for joining us for 3 and 4. This is about learning, and it's about trying and testing until you get it right. And when you get it right, it's like awesome. All right. And be confident and competent then to lead a team of robotics learners, and that'll be amazing. So thank you everybody for joining us. Thank you to my team. Thank you to Anzani. I think she's dropped off the call, but thank you to Casper and Elmarie for helping out. It's been a really good session, and hopefully we'll meet each other. Please make sure you get the mailing list. We do have a session next week, Tuesday and Wednesday, with environmental sciences and robotics. It's a really fun session to attend, and we'd love to have you join us then. Okay, so see you next Tuesday. Thank you, everybody. Okay, bye.